In the world of AI, things move so fast that progress is measured in weeks, not years. And this week, a new model just dropped that isn't just another update, it's a fundamental shift. We're about to look at an AI that is absolutely tearing up the leaderboards and challenging the biggest names in the game.
Okay, just look at these charts. On some of the toughest AI benchmarks out there, a new challenger called GLM-5 is going head-to-head with the giants. We're talking Claude Opus, GPT 5.2, and it's winning. It doesn't matter if it's complex reasoning, browsing the web, or writing code, it is consistently a top performer. This isn't just a small step up, this is a new contender for the throne.
And here's what makes this chart a really big deal, historically speaking. On the AI index, which bundles together 10 super tough evaluations, GLM-5 is the very first open weights model to ever score a 50. Now what that means is its core design is publicly available. Unlike those closed proprietary models, it's now outperforming. That's huge. But okay, benchmarks are one thing. What about the real world? Well, on Arena, this is where thousands of people blindly vote on which AI response is actually better for real tasks. GLM-5 has been crowned the #1 open model, and that's for both general text and for writing code. So this isn't just about passing tests, it's about being genuinely incredibly useful to actual people.
So the name behind all this excitement is GLM-5. And as we're about to see, its incredible success isn't just because it's bigger. It's because it's fundamentally smarter in how it's designed.
All right, so the wow is pretty clear, right? We have a new champion in the open weights world that's playing in the big leagues. But that just leads to an even bigger question.
How does it actually do this? How can a model deliver this kind of top-tier performance without needing a ridiculous amount of computing power for every single thing it does? Well, the answer comes down to two key innovations.
And this brings us to the how. The secret to all this efficiency, it starts with a revolution deep down in the model's core architecture. It's called Deep-Seek Sparse Attention, or DSA for short. Now that might sound complicated, but the core idea is actually simple, and frankly, it's brilliant. Instead of paying equal attention to every single piece of information it's given, the model learns to dynamically focus its brain power only on what's most relevant at that exact moment.
Think of it this way. The old method, that's called dense attention, is like trying to find one specific sentence in a book by rereading the entire book from cover to cover every single time. It's thorough, sure, but it's incredibly inefficient. The new way, sparse attention, is like using the table of contents and the index to jump straight to the right page. It's faster, it's smarter, and it's way, way more efficient.
And the impact of this is just staggering. Researchers discovered that with the old method, a full 90% of the calculations the AI was making were completely redundant. This new architecture lets the model just skip all that wasted effort without losing any understanding at all.
So what this means in practice is that GLM-5 can process enormous amounts of information. We're talking up to 128,000 tokens at roughly half the GPU cost of the older methods. But look, a smart architecture is only half the story. You also need a really smart education.
And this brings us to the second part of the how, a completely re-engineered training process. It's designed to create not just a database of knowledge, but a true problem solver.
As you can see from this pipeline, the model's training is this really carefully orchestrated journey. It starts on the left with pre-training, where it learns from a mind-blowing 27 trillion tokens of data. In the middle, mid-training extends its ability to handle really long documents. But the real magic? That happens all the way on the right, in the final post-training phase.
In post-training, the model basically goes through a three-step curriculum. First, it masters pure reasoning, logic, math, and science problems. Then it learns to be agentic, how to use tools and plan out multi-step tasks. And finally, it gets polished to be a safe and helpful general assistant. It's a clear progression from pure logic to practical action.
And underpinning this whole process is a brand new, much more flexible training system. It lets the model work on multiple complex problems at the same time, learning from them continuously without all the slowdowns that used to plague the older methods. So we've seen the wow, and we've gotten a look at the how. Now it's time for the now. What does all this mean in the real world? Well, it signals the dawn of something called agentic engineering.
To see what this new agentic ability really looks like, researchers gave GLM-5 a crazy challenge: run a simulated vending machine business for an entire year. Now, this isn't a simple question and answer task. It requires long-term planning, managing resources, and making decisions day after day. And the result?
GLM-5 didn't just manage the business, it turned a final profit of over $4,000, outperforming every other open-source model they tested. This is a real, concrete demonstration of what long-horizon planning looks like in action.
And this is what agentic engineering is all about. It's this major shift away from just giving an AI a simple prompt and getting one answer back, what some people jokingly call vibe coding, and moving towards building an AI that can function as an autonomous agent, one that can plan, use tools, and tackle complex goals all on its own.
A key technique that makes this possible is called interleaved thinking. As you can see in this diagram, before the model takes any action or calls any tool, it actually generates its own reasoning. It thinks, then it acts, then it thinks again, then it acts again. This step-by-step reasoning process makes its behavior way more stable and reliable when it's working on really complex tasks.
This one quote from the research paper just captures the entire shift perfectly. We are moving from a world of vibe coding, where you kind of just hope the AI gets the gist of what you want, to agentic engineering, where you empower the AI to be a capable, autonomous partner.
GLM-5, with its super efficient architecture and its agent-focused training, is a massive step in that direction. And it leaves us with a truly exciting question. If an AI can start to work with the kind of planning and tool-using capabilities of an engineer, what in the world is it going to be capable of building next?